Okay, so I have directions there in case you want to read through that on your own. So two or more terms on both sides, use opposite of order operations to isolate the x terms on one side and the constant term on the other, and then solve the equation. So just a reminder in question one, or all of these, only expresses a decimal if there's a decimal in the original question. Otherwise, it's fraction form, reduced in lowest terms, if needed. Okay, so here we have two x terms and two constant terms. What I always think about is, what's the smallest x term? That's the one I'm going to move. That avoids getting negatives. So between 5x and 3x is smaller. So I'm going to subtract 3x from both sides. And so that will go away. 5x minus 3x is 2x. I copy out the 6, the equal sign, and I'm left with 14. Don't try to do all the work on the side on your own, step by step. So one step for dealing with the x's. Now the other step to get x by itself is dealing with the constant terms. So I'm going to subtract 6. So 2x equals 8. Now it's the same answer as the last one, right? We're going to divide by 2. So x equals 4. Right. Any questions on that? All right, so next one here, two terms with x, two constant terms. What's smaller, negative 6x or positive 2x? Smaller is the negative one. So I would do, it won't be, it's fine if you do it the other way, but I'm going to add 6x. I'm just going to make that a little smaller. I'm going to add 6x to both sides to get rid of the x on the left. If you bring the 2x over, you'd be subtracting 2x, which is fine. You'll just have a negative x term that you have to deal with at the end. So now we're left with 4 equals 8x minus 20. Okay, circle the x term. Got to get rid of negative 20. So we add 20 to both sides. And so that's going to be 24 equals 8x. And then divide by 8. Remember that I like showing x first. So then I'm going to say, okay, when I divide by 8, I get 3. So that's going to be x equals 3, rather than 3 equals x. Okay. So next one also has the same, these are all kind of similar in the fact that they have two constant terms, two x terms. When I'm dealing with negative 7x and negative 5x, what's smaller, negative 7 or negative 5? Negative 7. So I'm going to add 7x to both sides. So that will go away. So I'm left with 8 equals 5. Now negative 5x plus 7x is 2x, so plus 2x. Going to circle the term with x in it. That's what I have to get by itself. So I'm going to subtract 5 from both sides. And so I'll get 3 equals 2x. Well, 2 doesn't go into 3 evenly. No decimals, so we'll use fractions. So we'll just divide by 2. So x equals 3 over 2. Remember how I said in high school math, we don't even convert that to a mixed number anymore, very rarely. So x equals 3 over 2. Don't bother showing it as 1.5. Okay, we leave it as an improper fraction. It's already in lowest terms, so you're good on that one. Next one has decimals in it, so you can give a decimal answer if it ends up being a decimal. If you want to use a calculator, you can, but you might not necessarily need to. In terms of the x terms, 10.2 is smaller, so I'm going to subtract 10.2x from both sides. Well, 12.2 minus 10.2, the 0.2's subtract out, and so 12 minus 10 is 2. So that's going to be 2x plus 3.4 equals negative 5. Then we subtract 3.4 from both sides because we're trying to get that x term by itself. So that's going to be 2x equals negative 8.4. And then divide by 2. And you might not need a calculator for that. Remember, 2 goes into 8 4 times. 2 goes into 4 twice. So half of 8.4 is 4.2, not 4.1. 4.2. I said it, but I didn't write it properly. Okay, so turn over the page. And we get into equations that have brackets. So this is all now, this gets into stuff that you did in Math 9. You did some questions with brackets. Math 9, you also did more with fractions. We did a few last week. You did more with fractions. We're not going to get into too many with those, but I did want to review for sure what to do with brackets, because really it's a review of working with polynomials anyway, distributive property. So it says use the distributive property to expand and get rid of the brackets. There are times where you could divide right away by that number outside of the brackets, but it doesn't always work. If it doesn't go in to the number on the right, then it's really hard. So the best practice then, so that you can do the same method for all equations with brackets, is to get rid of the brackets. And then you solve it like you've been doing so far. So here, when I expand, remember it's called the distributive property because you're distributing the 2 into everything in the bracket. That's 2x plus 10. And then you copy out the rest, equals 18. Now, just have to isolate the term with x. So we subtract 10 from both sides to get rid of that 10. And then we divide by 2. Okay. Should be copying out these exact same steps that I'm doing so that you have something to refer to when you're doing them on your own. Okay. Okay, expand the next one. 3 times x, 3 times negative 4. What do you get? So you're going to do B and C right now. Okay, so there are the solutions to B and C. D, same steps. You'll notice that just on the right-hand side, it's got an x term. So maybe we'll have to group the x's first, but we still want to expand out the brackets. first. Oh, sorry, that looks, there we go. 8x minus 24 equals 7x. Now, two terms with x's in it on either side. So I always start with getting those together. And yeah, 7 is smaller than 8, but if I bring the 7x to the left, then the right side is 0. So just like on Friday, I'm actually going to leave the x term that's by itself on one side and get rid of the other one so that I still have just one x term on one side. It will give me a negative in this case. So 7 minus 8 is negative 1, so that's going to be negative x. And then I need to then divide by negative 1. Really, I'm just changing the sign. So now x equals positive 24. Oh, yes, it is. Who found that? Good, good. Oh, it's a Monday for me, isn't it? Okay, so thank you. Just checking to see if you're awake this morning. That's all. Minus 12. Good. So I have to change that part of it. And then the answer is positive 12. Thank you. Sorry, I don't know what I was thinking. 4 times 3 is 12. 12, 12. Okay, now more terms even. Doesn't change anything. Still have to get rid of the brackets. And then collect some like terms, obviously. You pick up a notes sheet. You late for a reason? No. Great. So 9x plus 6 equals 3x. Now it's minus 24. Okay. And so now it's like the questions we were doing on the first page. There's an x term and a constant on both sides. So now I'm going to look for the smallest x term. Okay, and then, so that goes away. 9 minus 3 is 6x plus 6 equals negative 24. And I want to get the x by itself, so I've got to subtract 6. So I'm running out of space, so I'll just move it to the right. That goes to 0. So now 6x equals negative 24 minus 6 is negative 30. And divide by 6. So x equals negative 5. Okay. In F, 2 brackets, one on the left, one on the right. So you need to expand out both before you can start solving anything. So always think, get rid of the brackets first. Distributive property. So 2 times x plus 2 times 7. 3 times x plus 3 times 6. And then it's the same deal. X is on both sides, numbers on both sides. So smallest x term is 2x. If you want to subtract 3x from both sides instead, you can. You'll just have a negative at the end that you divide out. So now 14 equals x plus 18. Okay, and that one's pretty straightforward because it's just x. So when we subtract 18, 14 minus 18 is negative 4. Okay. Pardon me? Okay. All right, same thing in G. I want you to expand that out in G, both sides. Okay, so G is done there. H, as I said, it's same process but with fractions. So when you multiply a half times 4, half times 8, you get 4. A half, remember 8's like 8 over 1, so that's going to be 4. A half times negative 6, well, a half of negative 6 is negative 3, so subtract 3x. 3/4 of 12, I made them sort of nice fractions, but if you want to show that as 12 over 1, then that's going to be 36 over 4, which is 9x. And then 16 over 1, 3/4 of 16 is 12. Or you can go, okay, that's 48 divided by 4, which is 12. And it's negative, it's subtracting. Okay, now it's just like the others. X is on both sides. Smallest is negative 3x, so I'm going to add 3x to both sides. And so then get it black and blue, 4 equals 12x minus 12. Then add 12 to both sides. And divide by 12. Okay, so x equals 16 over 12. Now, that can be reduced. So make sure you do that simplification. 4 goes into 16 and into 12. So that's going to be 4/3. And again, we don't show it as a mixed number, just as an improper fraction in lowest terms. And last one, it's got decimals. So again, if you want to use your calculator, you can. And you can give the final answer as a decimal if it ends up being a decimal. Could be a whole number, you never know. So expanding out, 1.2 times 3. So if you don't have a calculator, you don't have to have one in this case. So think of 1 times 3 is 3. 0.2 times 3 is 0.6. So that's going to be 3.6x. And multiplying 1.2 times 0.4. Well, 12 times 4 is 48, but we've got decimal in there. So that's going to be minus 0.48 because there's 2 decimal digits. But you can use your calculator if you like. And then 2.2 times 2.01. Well, 2 times 2 is 4. And 2 times 0.01 is 0.02. Plus, well, 2 times 8 is 16. with one decimal place is 1.6. Okay. And then smallest x term is 1.6. So I'm going to subtract 1.6x from both sides. Computer's very slow right now. Okay, and then isolate the x term. Worked out to be a whole number when I collected the x's. I'm going to add 0.48. Okay. And so when you add 0.48, think of money. $4.02 plus 48 cents is $4.50, 4.5. Okay, and then we'll divide by 2. So if you, again, because there's decimals in the equation, we'll give a decimal answer. So 4.5 divided by 2, you can use your calculator, but 2 goes into 4 twice. And then 2 goes into 5, well, 0.5, 0.25 times, right? Think of 50 cents. $4.50 divided by 2, it's $2.25. So sometimes if you think about decimals as money, it helps a little bit.